So we talked about last time how when you place electrons on one side of a conductor and cause them to flow from the left side of the conductor to the right, this flow of electrons is called current. In other words, more electrons per second means a higher amount of current. As the electrons flow from the left side of the conductor to the right, they experience some bumping and jostling around due to the nuclei in the material, and this resistance to the flow of the current is called the resistance of the material. Also, how electrons, as they move from one side of the conductor to the left, they lose a certain amount of energy over the distance that they travel, and this energy loss is called voltage, when you take the energy and you divide by the charge of each individual electron. So, what causes, let's say, some electrons to flow from the left side of the conductor to the right? Well, electrons are negatively charged particles, so if you have two electrons next to each other, they're going to want to repel from each other. So, suppose if I have a lot of electrons on this side of the conductor, well, they're going to repel each other and want to move to the other side of the conductor, or at least spread out. So they're going to at least want to just spread out throughout this conductor. So how do we make a sort of constant flow of electrons? Well, one way is with a battery. So if I have a battery here with positive and negative terminals, what does the negative terminal mean? That means there is a lot of electrons on this side of the battery. And so when I connect a battery from this side to this side, a bunch of electrons are going to flow from the very dense side over to the negative side, the positive side of the battery, which has a lack of electrons. Now, when you have a lot of electrons pushing against each other and sort of really, really wanting to move away from each other, we say that these electrons have a lot of energy and a lot of voltage because they're all packed together and sort of compressed like springs. Now, once they move to the positive side, so I'm going to say this is the negative side and positive side of the battery, they're going to be more spread out, and so they're going to have a lot less energy. So if you think of these electrons all packed together like springs, which means they have a lot of voltage and energy, well, it should make sense then that all of these electrons all packed together having a lot of voltage means more voltage, which means they're going to flow more quickly through the material, which in other words means more current. So more voltage is going to cause more current to flow. In addition, though, all of these resistances inside of the material is going to slow down the current. So now the current is going to be slowed down due to an increase in resistance. We can write this as an equation just as current is equal to voltage divided by just the resistance. So more voltage means more current, and more resistance means less current. And so we typically write this as I equals V over R, and this I right here is due to French, and it was basically called the intensity of current. So the I is basically for intensity, and this equation is sometimes rewritten as just V equals IR. And what we say is we call this Ohm's law. And it's a pretty straightforward property, just that an increase in current is going to cause an increase in voltage, and that increase in resistance is going to cause a decrease in current.